Hi, Assalamualaikum and good day everyone. I am Mohamad Faris bin Mohamad NAHAR, representing my Group 2 of Engineering Mathematics 5 of University Tun Hussein of Malaysia. And now I'm going to present about our assignment. And this is our data, these two data, which our water pH is our independent variable and water quality index is dependent variable. And from the task given, we are required to find the mean, standard deviation, minimum value and maximum value. And from here, to find the mean, we just have to use the formula average and just drag from the top of the table to the downside of the table. And same goes for quality index. And for standard deviation, just input the stdev.s and just drag from the top of the table to the bottom of the table. And same goes to water quality index. And for our minimum value, it is 7.23, and you can see it here. And our water quality index, the minimum value is 88.98. And our maximum value is 7.55 for water pH. And for water quality index, it is 92.78. And after that, we construct a scatter diagram by looking on this from charts from the insert panel, and you can from the group of charts you can see the option of scatter and just click it here. And then we decide to use the linear regression line, and then we construct it here as required from our task. And then for the third one is we need to find the least square method to find the simple linear regression. In the sheet 2, we added the additional three tables. From the first one is x square of water pH, and the second one is y square of water quality index, and the third one is xy, a multiplication of the dependent variable and independent variables. And we sum it up and tabulate it here. And this is the sum total of from all of the table. And to find the least square method, the formula is y bar is equal to beta 0 plus beta 1 and times with x. And to find the beta 0 and beta 1, we need to find the x, xy and the xx. And the formula is for xxy, it is x square minus with x square over 100. And for xxy, it is xy minus with x times with y over 100. And after that, we need to find the formula of beta 1 first, because to find the beta 0, it is required for the value of beta 1. And for beta 1, it is just sxy divided with sxx. And for beta 0, to find beta 0, the formula is x square over 100 minus with beta 1 times with x over 100. And you can see here, this is for where we already input it. And then to find the linear regression model, we are required to use the data analysis, but in this computer the data analysis isn't shown up, but I already installed it, but I don't know why. Let me show you. To find the data analysis, you just have to click over here and then click the data analysis from the data panel over here, and then find the regression one. Click OK. And then for input y range, I've decided to use water quality index as y, and for input x range, I decided to use water pH. And then tick labels, and confidence labels is our alpha. In confidence labels, it is shown 95%, but it is assumed as 0.05 alpha as the conventional value. Then for output range, just click anywhere to place where it will be resulting up. Then click OK. So this is our results that will be shown. Then it is shown the summary output and ANOVA, which you can see here. And moving on to the next part, which we are required to test the hypothesis of when the null hypothesis beta 1 is 1 and the null hypothesis beta 0 is 0. And using the same level of significance, which is 0.05, alpha 0.05. And this is our results. And how I do this, I need to show you once again from the other computer, since this computer doesn't have the data analysis. And here, to find to test the hypothesis when beta 1 is 1 on independent data, you need to find the data analysis and choose the t-test to sample assuming unequal variance. Just tick OK. And the variable 1 range is what we want to find, and just for variable 1 range, just drag all the data from water pH, since we want to find test the hypothesis on the water pH, and just drag over here. And for variable 2, just drag on the water quality index. And for the hypothesized mean difference, just fill on value 1, since it's required when beta 1 is 1, and the alpha is 0.05, the level of significance. And output range, just click on anywhere, and then tick OK. And after you tick OK, the result is shown here. And by following the rule, first one is reject null hypothesis if t statistic is more than t critical, and the second one is reject null hypothesis if p value is less than 0.05. So it can be concluded that the null hypothesis is accepted. And for the second one is when beta 0 is 0 on independent data. And same here. The same goes for beta 0 is 0. The null hypothesis is also accepted. And the next one is to test the hypothesis when beta 1 is 1 on dependent data. Same goes for the rule. And for the conclusion, we decide to reject the null hypothesis H naught, since the t-stat is more than t critical and the p-value is less than 0.05. And it's same as to test hypothesis when beta 0 is 0 on dependent data, which we want to focus on water quality index. And we also reject the null hypothesis since the t-stat is more than t critical. And for the last one is to calculate the coefficient of Pearson correlation test. And from here, the correlation, the Pearson correlation is represented by R. And to find it, we've just input the Pearson over here, and in the bracket, we just drag from the water pH to the bottom side of the data, and comma. Same goes to water quality index from the top to bottom. And from the end is represent our data, our total of the data, which we choose 100 data. And t statistic is just like this. And our degree of freedom is our number of data is minus with 2. And our p-value is just input the TDIST and bracket F6, which is our T statistic, comma with F7, which is our degree of freedom, and then 2, presenting 2 samples. And then to find the coefficient of determination test. Please be noted that to find the coefficient of determination test, we need first to find the Pearson correlation test because it requires the coefficient of determination. The result of the combination of determination is requiring the Pearson correlation test, or we can just simply square root the value of coefficient r here over here, and we just simply get the answer of coefficient of determination. And that's all from me. Thank you very much for watching, and I hope to see you next time.